Hey guys, welcome back to the channel. Today we are going to discuss the last method for solving recurrences, which is called the tree method. After finishing this session, we are going to finish the entire recurrences subject. So let's dive into solving recurrences using the tree method. Although our two other methods are good enough to solve recurrences, but when we talk about substitution, a good guess is not always possible. And in those cases, a tree method can work very well. So either we can use the tree method to solve a recurrence, or we can use the tree method to guess a solution, and then we can use the substitution method to verify the solution or the guess. So in the tree method, what we do is we divide the problem and draw the problem as a tree. Then for every level of the tree, we sum the cost, and then we sum all these costs for all the levels to find the solution to the recurrence. Generally, the recurrence would look something like this when solving using the tree method. And if you see here, let's say we have the original problem here, then it's divided at the first level, and we take the sum of all the costs, and let's say we say the sum is S1. Then we further divide and take the sum, let's say it's S2. And we keep on dividing until the problem size reaches 1. And let's say the sum is Sn. Then the final solution would be summing all these sums at every level, and this will be our solution. Let us dive into an example to better understand how to use tree method for solving a recurrence. So let's start with a more easier example. Example 1. The recurrence looks something like this. Okay. Now, if you see, and if you are following my other videos on recurrences, you can see that the problem is being divided into half, and the function is called recursively twice. If you are not able to understand this concept, I would recommend you go back and look at how we derive recurrences out of code to better understand what this recurrence means. So now what we are going to do is, in the tree method, we look outside the recursive call and we take the cost outside of the recursive call. So we are going to focus on Cn, where C is a constant, and then we have n work which we are doing with every recursive call. So we are going to write it like this, Cn. So at first level, we are doing Cn work and the total is Cn, and this is our 0th level. Okay. Now the problem is being divided into half and we have two recursive calls. So the tree will look something like this for n upon 2. This is our first level. Right? So when we are doing n upon 2, we are calling the recursive function twice, which we can see here, and the problem is being divided in half. So if we sum this, what we are going to get is Cn, right? N upon 2 plus n upon 2 is n, and then we have C for every n upon 2. Going further and doing the same thing, we are again going to divide it by 2, which makes it n upon 4. And this is our second level. So it will be like this, and this will turn out to be plus C n upon 4 plus C n upon 4 plus C n upon 4. So at second level, we are doing this much work. So there are 4 recursive calls. Here we have 2 recursive calls, and here we have 1 recursive call. If we sum it, we are going to get Cn again. Going like this at ith level, which means we keep dividing the problem until the problem size is 1. If we generalize, we will get n upon 2 raised to the power I plus right, and the sum will be Cn. Okay. This means if we see, we are going from 0 to I. That means going from 0 to I is I plus 1 times 0, 1, 2, I. Right? So we have divided the problem until the problem size is 1, which means we have reached the base case, which is T1. Right? This means this is T1, or we can say is equal to 1, or I is equal to log base to n. right? Now, as I described, what we are going to do is we are going to sum at every level, and then we are going to do the sum of all the levels. This means we are going to do is Cn plus Cn, Cn, and how many times? I plus 1 times, right? Because 0th level, first level, second level, and ith level. So we are going from 0 to I, and we are going to sum Cn I plus 1 times. This will turn out to be if we take Cn common, and I plus 1 times. And what is I? I is log base to n, right? So if we sum these I plus 1 time, we are going to get, right? This means and if we ignore the lower value, we can only keep this, and this will turn out to be, and this is our solution for the recurrence. Okay. Let's do one more example to understand the concept better. So our next recurrence is going to look like this. Is a little more complicated than the previous one. So if we see, the problem is being divided in half, but we are calling the recursive function 4 times. 4 times in half, right? So let's see how this goes. At the 0th level, we have Tn, and we will focus on the non-recursive part of the recurrence, as I discussed in the previous example. Okay, and the sum is n square. Now, when we go on to the next level, we are going to divide the problem size by 2. This is our first level, and this will be 1, 2, 3, and 4. So we are going to substitute n upon 2 for every n. And the sum will be n square. Basic maths should not be too tough. Okay. Okay. Let's move on to the next level and divide n further by 2. So this will be okay, right? This is second level. Here we have 4 terms. In the next level, we will have 4 raised to the power 2, 16. So we will have 4 raised to the power 2 terms. And if we see, the sum will still be n square. So similarly, going like this until we reach at level I, and we will get ith level. And this means going by the previous trend, we are going to get n square, and this will be I plus 1th level or row, because we started from 0, 1, 2, and I. So this is I, right? Okay. So this means our last level should be where the problem size should be 1, which is the base case. And so n upon 2 raised to the power I should be 1, or I should be log base 2 n, right? Same way, we are going to sum all the levels, 0th level, first level, second level, third level, until ith level, which is actually I plus 1th level. So our recurrence will look like n square plus n square plus n square. This is I plus 1 times we can say I plus 1 times. And I is log base to n. So this will be, or right, discarding the lower value, we get our solution to the recurrence. This is our final solution. I hope you are able to follow my explanation. If you are not able to follow anything, I would highly suggest that you write comments for me, and I am going to have a look and explain whatever parts you are not able to understand, and maybe I will do another video in a little more detail so that you are able to understand properly. Okay, so I am going to do a third example, which is a little more difficult compared to our last two examples. So the recurrence looks something like this. If you notice, the problem is being divided in fourth, and the function is called 3 times. Okay, so let's see how our 0th level looks like. We are going to take the non-recursive part, as I mentioned in previous two examples, and the sum is going to be this, right? Okay, let's do the next level. So the next level is going to be n upon 4. Every time we are going to divide the problem by 4, unlike our previous examples where we were dividing the problem in half. Okay, so you have to understand how the problem is being divided. Don't always keep dividing by half. Have a look at the recurrence, how the problem is being divided. Okay, so we do n upon 4. This is our first level, and we are going to call it 3 times, right? So replacing n by n upon 4, right? The sum will turn out to be, let's see, C 3 n square, or we can say n upon 4 square, right? Okay, now at the next level, every problem is being divided by 3. So these were 3 terms Next, we will have 9 terms. So if we do second level, it will be n upon 4 square, and we can say n upon 4 square, right? C n upon 4 square. And this is 3 raised to the power 2 terms, which is 9 terms. And the sum will turn out to be C 3 square n upon 4 square and the whole square, right? Now if we keep on going like this, we will have the ith level, which will be like this, and which will be like this, and these will be 3 raised to the power I terms. Mind it, this is 0 to I, which is I plus 1 rows or levels, as described in our previous examples. And this will turn out to be C 3 raised to the power I n upon 4I square, right? Okay. Let's see. This means we have gone to ith level where the problem size should be 1 or the base case. This means should be 1 or I should be log base 4 n, right? Okay. Now we are going to solve this problem in a different way, a little bit different. If you see the series is coming out to be like this. So, okay, let's see how the series look. The series is Cn square Cn square plus C3 n upon 4 plus C3 square n upon 4 square plus C3I n upon 4I square, right? Or we can write it like this. Cn square plus C3 n square upon 16 plus C3 square. So we are expanding the outer square for 4. Okay. This will be n square upon 16 square plus If I write the next term, it will be n square upon 16 cube c 3i n square upon 16i. Okay, and these are I plus 1 terms. If you see, it's a, let me simplify this a bit so that you are able to see the pattern. So I am going to write it like this. So this is, okay, here is a little catch. We have I plus 1 terms, which means we have I terms plus 1 term. Okay, and this 1 term, the last one, is our last level. Okay, so we are going to solve the last level later. Let's see how these I terms look like. If you see the pattern, this is looking like right, and this sequence is 1 plus r square. All right, the sum is one upon 1 minus r plus right, and r is equal to 3 upon 16. So this will be cn square 1 upon 1 minus 3 upon 16 plus cn 3i upon 16i, right? Okay, so we are done with solving this term. Now let's take this one. This is our last level, which is I plus 1th level, right? So at this level, I'm sorry, here. At this level, if we notice, all the terms or all the problems should be of size 1. So we can say at level it is t1 plus t1 t1, right? Let's take this, and these are how many terms? 3 raised to the power I terms. Let's take this at the bottom. So then the last level is T1, 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 right? And this is I 3 raised to the power I terms. Raised to the power I terms. Now I is equal to log base 4 n. So then if we sum these, we are going to get 3 raised to the power log base 4 n, or we can say n raised to the power log base 4 3, right? So if we put this instead of this, which means at the I plus 1th level, we are going this much work. So the total cost would be Cn square 1 upon 1 minus 3 upon 16 plus n. Okay, sounds good. Okay, and this will be 16 upon 13 Cn square plus, and because this is the total time, we can say it looks like this. So this is okay. Now discarding the lower values, constants, what we get? And that's our solution to the recurrence. We discarded all these lower values or the constants. So what we did is we took the sum excuse me, we took the sum of 0, 1 and I minus 1 level, which is I 0 to I minus 1, and then this level we took out the sum separately, and then we summed this plus this to make it more easier to understand and find a solution to the recurrence. If you're not able to understand this solution, maybe I will suggest watch this video a couple more times to understand. And if you still have doubts, post in the comments what exactly you are not able to understand, and I will try to do another video, or maybe I will try to explain in the comments so that you have a better understanding of this recurrence solution. I hope today's session on the tree method was helpful and gave you some knowledge on how to solve recurrences using the tree method. I'm going to end this session for now. Thanks for watching and bye.